The distributive property talks about multiplying a number across addition or subtraction. So we'll want that definition. This is my own definition. I didn't like the way the book worded it. All right, and the way I'm going to show this to you is by taking something simple as 1 plus 2. We know 1 plus 2 equals 3. And as we're going to see and review, if ever you want to change one side of an equation, you're also going to have to change the other side of the equation the same way. So for instance, if I wanted to double 3, I can do this. I would also have to double this side to make sure that they stay equal. Okay, so that's what we have to do. We're going to see that when we're trying to solve for different parts of an equation. But if I double both sides, this now becomes 6. And what actually happens is you could do 1 plus 2 and get 3, and see that 2 times 3 is going to be 6 as well. However, this is also true. I can take 2 times 1 and 2 times 2 and get the same thing. So 2 times 1 is 2, plus 2 times 2, which is 4, and we still get 6. 2 plus 4 equals 6. All right, so that's kind of where the distributive property came from. And a lot of you are probably thinking, well, if I have a problem like this, why would I even use the distributive property? You don't have to if the problem actually looks like this, unless they are asking you to do so on a test or something. But what we can do here is look at, okay, what is 3 plus 9? It's 12. Okay? And then 5 times 12 is 16. I can definitely do it that way, but we're just trying to show you that the distributive property also works. What I like to use is, I call this the box method. I also call it a train. Put some wheels on it, a smokestack, got a train. So you can call it that if you want to. Crazy Train, whatever. Good song, by the way. But you can take your 5, put that there, and then your other two numbers, 3 and 9. You do want to include this positive with it, so that you know that that's positive. But anyway, you're going to take 5 times 3, and you'll get 15. And then 5 times 9, you get 45. And what you have here is 15 plus 45, which equals 60. So that is that. Now, here is the last example where you're going to want to actually use the distributive property because you don't know what's on the inside. 2 plus x. Now we're starting to get into algebraic territory. Okay. If you use the box method or the train method, here's what this looks like. We'll put 3 out front, and then we've got 2 up here plus x. Now, if you don't see a number in front of x, we consider that a 1. 1 times x is still x. Remember, 1 times anything is the same thing. So here's what we do. We do 3 times 2, which is 6, and then 3 times 1 is 3, but then we also have an x there too. So this turns into 6 plus 3x. And many of you are probably thinking, well, I don't want to draw out that box thing. Can't I just do 3 times 2 and 3 times x and get this answer? Yes, you can do that. You just have to be careful when you do that. And remember, if the reason we're distributing this via multiplication is because we have these parentheses and there's no sign in between these. It's 3 next to a parenthesis, which indicates multiplication, kind of like it did up here. 5 times whatever you get here, or 3 plus, or 3 times 2 plus x. All right, so it's getting used to this situation when there's an unknown in your parentheses. That distributive property is going to be a huge deal. All right, and we'll get further into that tomorrow. So that's all I have for distributive property.